Hi, thanks for coming to our talk on building a shared conceptual model of complex heterogeneous data systems. Here's a diagram of an old-fashioned database system. One piece of software, maybe one piece of hardware, under the control of a single organization who can determine both the users and the applications that use it. Here's just a sampling of the pieces of software that we have to grapple with today. And here's just a sampling of the number of people using that software today. We have a huge number of organizations and a huge number of individuals, all of whom have to coordinate their data activity. They do that imperfectly today when they do data sharing. And although data sharing is everywhere, the shared models that we have to moderate it are not really up to snuff. There are relational schemas, of course, but they're limited to relational databases. XML standards and similar specs exist, but they're not widespread and not common in every single domain. Data catalogs are a relatively new category, but on the downside, they're expensive to build and pretty limited in reach. A lot of these efforts at creating high-quality models to enable better data sharing and better data coordination end at the organization's edge. This makes life painful for all sorts of parties today. Data scientists often have the problem of communicating details about their pipelines. They need to share internal information about what models they built, files, and so on. And they need to coordinate with others on definitions of correctness and features, etc. Experts in data governance similarly have to communicate policy to one another and coordinate with each other on the definition of rules. And finally, data consumers have to communicate about the provenance of the objects that they're looking at and coordinate about which trusted sources to actually employ. All of this would be vastly easier if we had a universal shared model, something that could describe the data sets that we're using and what we do with them. So let's build it. That might seem ludicrous, but hear me out. Now, of course, federation, integration, standardization, these are often excruciating and tedious processes that are expensive and error-prone. We've done a lot of work, both in industry and in research, to make that easier, but it's still painful. And so a single universal prescriptive model is going to be pretty tough. However, we have lots of evidence that we can definitely build a massive descriptive shared data set. In fact, we've already done it. One thing that I hope people will take away from this is a topic that is gaining in prominence, but it's still not widely appreciated, I think, in the data management community, and that is knowledge graphs. These are an underappreciated and astonishing data success story of the last few years. They have achieved enormous scale with a consistent schema throughout the data set at a cost of scalable curation. Let me just give you one graph that describes Wikidata, one of the most well-known knowledge graphs today. Wikidata is the structured part of Wikipedia. Here you can see its data growth over time. In 2014, it had about 53 million facts or statements, and at the end of last year, it had almost 1.2 billion of them. Its growth has been absolutely amazing over the last few years. And if you examine it in detail, you'll see that the quality of that data is really high. Here's a couple basics, a little bit of background. It's a socially curated database, but it's a graph database. The deduplication of entities and properties is remarkably good. They don't do that through traditional schemas, but rather via an editing interface that's constantly auto-suggesting pre-existing objects. It's actually a lot of work to not go with the standard work that others have done before you. And while adding new data is easy, adding new properties requires a lot of social discussion and approval. Unlike traditional schemas, it's descriptive and only informally prescriptive. And although it's always somewhat broken, it's always pretty useful. So we have a suggestion for what we call the knowledge network programming system. Our prototype tries to build this universal shared conceptual model in 3 steps. First, automatic and low resolution recording of data operations. We're not going to integrate with every tool out there. We're just going to use whatever facilities the operating system offers us. We're going to combine that with automatic combination of everyone's provenance records. So as people collect records locally about what they're doing, we're going to collate them into a single shared location. And then finally, we're going to use Wikidata style social curation to make this global record of data operations useful and valuable to people. It will always be somewhat inaccurate and incomplete, but we think a broad but flawed consensus picture of the world's data objects and processes is going to be really valuable. Here's a rough architecture. At the bottom level, we have a lot of data performing system, your laptop, server, your AWS deployment, and so on, with a KNPS client watching what's happening on all of those systems. After they collect local data, it's uploaded and coordinated with a single, that should create a single low-level global provenance graph. Now, provenance is very weak here. It's just recording file copies, processes that are launched, and so on. But after we create that global graph that crosses organizational and team boundaries, we can then fix it up. That coarse description of reality can be refined with the application of those wiki-style operations that I mentioned earlier. We can apply queries, rules, automatic and human annotations, and trained classification services on top. All right, so imagine the following data consumption story. This will try to illustrate how we think the system can be valuable. User Alice downloads some data from the New York Times, all about COVID. She edits the data and mistakenly adds some misleading data points, goes on to create a visualization and shares it with a colleague, Bob. She writes an email, "Hey Bob, check this out. Kind of amazing stuff, huh? You won't see this in the news." And here's the story. Daily COVID cases in Massachusetts were flat for a while, but then go to zero at the beginning of December. Bob is rightfully a little bit suspicious and wants to check out if it could be true. In a traditional mechanism, this would be extremely difficult to do, but our system allows that to happen. Now, this is a pretty lurid example, but a lot of questions about data in those three different communities that I mentioned all have this form. Let's switch to a demo of our system right now and see how it works. Bob, at this point, has downloaded the visualization that he received as an email attachment that's been stored to a local file system, been synchronized with the KNPS client, and now Bob is looking at the KNPS dashboard. In this case, there's only a single file. That's a little bit unusual. We would generally expect lots of files to be under management, but it keeps things simple for this demo. That file, that visualization, is the one that's called Massachusetts COVID plot.ping, listed at the bottom of the screen. Let's click on it and get some more information so Bob can explore whether this visualization that he received is really trustworthy or not. Here we have all the information that the system knows about this particular file. In the upper left-hand corner, you get some basic metadata: the name of the file, its owner, when it was last modified, different version identifiers, and so on. The most useful part at this point is the provenance chain that KNPS has been able to assemble by watching ongoing activity at multiple locations and can present to Bob. Now, because this data object crossed both a tool and an organizational boundary, generally, this provenance back history, how did this visualization come to be, would be totally lost to Bob. The only way that he would be able to get access to it would be to send emails, ask questions, and generally engage in a time-consuming archaeology-style hunt. But in this case, it's all in front of us. What we can see here, we can highlight this and look for more details, is, yep, this is the visualization. This is the right file. It's an uncurated data file. That is to say, no human being has annotated or given the KNPS system any additional metadata about the object. It's simply an observed file. We can see that it has zero known uses. That is to say, it's not the input to any process that the system is aware of, and has one other known copy in the world. There are only 2 copies of this content that the system is aware of. That other copy predates the one that we're looking at, and so the system can infer a likely sharing event. Now, KNPS doesn't instrument Gmail. It doesn't know exactly what the browser is doing or how the file got here. But simply because we've seen the file at one location at a different time, and then later observed exactly the same content at a later moment, we can infer that some kind of sharing happened. Let's go back further in time. Here we have a different file, has the same name. This is the source of that sharing event. This is on the sending end of the email attachment. But how did this file come about? Well, we can see that it was the output of a program called Excel that ran at a particular moment in time. And that Excel, its input was a file called data.plot.csv. Now, that's already somewhat suspicious. If this visualization were really built on trustworthy data, we wouldn't expect this data file to be totally uncurated. We wouldn't expect this to be the only known copy in the world. Rather, there should be a community of people using it. So Bob already has some reason to be suspicious of Alice's data process here, but KNPS has captured even more information that we can use to explore. If we keep going back in time, we can see that that uncurated data file was the output of Emacs, and that Emacs, its input was a curated data object called New York Times COVID data. So what appears to have happened is that Alice did get some curated data, the New York Times COVID data object, had it stored as a local file. We can get information about that local file by highlighting it here. You can see in the left-hand side all the metadata, the content that's been cached in the lower left, and a little bit of usage information, how many other copies there are, how many times it's been used, and so on. Now, the most important part about this is that this is a curated data object. The contents of this file match a piece of data somewhere in the world that human beings have actually curated and talked about, much in the way that they do with a page on Wikipedia or Wikidata. Let's go to that and see a little bit more about it. Here we can see the curation information. So it's the official New York Times COVID data object. It contains case data up through December 5th, and so on. We can edit this in the same way that we might try to improve a Wikipedia page. So I might add to say that this is New York Times COVID state level data. But as it stands, we've now been able to answer a question. Bob is right to be suspicious about this visualization and shouldn't trust it at face value. But he can take a further step. We can now revisit that data object, revisit the content inside that data object, and we can curate it. This whole process of going through that provenance chain, some automatically observed objects, others that have been partly curated, has given Bob new insight into the world. That is to say that this data probably isn't trustworthy. We should record that so that Bob and other people can benefit from it. So I'm going to curate this content and say the name of this visualization is Bob Alice Massachusetts COVID viz. And the description is, it seems potentially untrustworthy. Seems based on a mutated version of the New York Times official data. I can add comments just like I would in the work pages of Wikisystem. Alice, did you really mean to do this? If I then go back to that file, we can now see that my annotations have improved my own record of my own data objects. And if Alice goes back and examines it from her perspective, she'll benefit from my annotations. Thanks for listening to the talk. I'm happy to take questions.